Next, Benedict's reagent. So, oxidation with Talon's reagent and Fehling's reagent is there. So, in both reagents, only aldehydes reacts with those reagents. Talon's reagent and Fehling's reagent. But ketones does not respond to Talon's and Fehling's reagent. And one more reagent which is used for the identification of aldehydes and ketones, that is Benedict's reagent. So Benedict's reagent is mixture of copper sulfate and sodium citrate, sodium carbonate solution. Okay. So Benedict's reagent, this is mixture of copper sulfate solution with sodium citrate and sodium carbonate solution. So that is Benedict's reagent. So aldehydes forms red color precipitate with Benedict's reagent, whereas ketones does not respond to Benedict's reagent. So same reaction as Fehling's reagent. Okay. So aldehydes forms red color precipitate. Ketones does not form any precipitate. So no reaction with the ketones. So aldehydes, they gives red color precipitate. Ketones no reaction with the Benedict's reagent. Okay. Next, Schiff's reagent. So Schiff's reagent is also used for the identification of aldehydes and ketones. So coming to the preparation of Schiff's reagent. Para-rosanilene hydrochloride, which is a pink color solution, that is first gets decolorized by passing sulfur dioxide gas. Okay. So we get colorless solution which is called as Schiff's reagent. Okay. So para-rosanilene hydrochloride. This is pink color solution. Pink color solution. Okay. Pink color solution decolorized by passing sulfur dioxide gas. Okay. Colorless solution formed is called Schiff's reagent. Colorless solution formed is called Schiff's reagent. Colorless solution formed is called Schiff's reagent. So Schiff's reagent also gives test only for aldehydes, but not with the ketones. Okay. So aldehydes with the addition of Schiff's reagent, pink color restores. Okay. Aldehyde solution is also colorless. Schiff's reagent is also colorless. Okay. So aldehydes restore pink color. So pink color of Schiff's reagent reappears when it is added to aldehydes. Whereas ketones no reaction. For ketones no reaction is there. So that is with the Schiff's reagent. Next, legal test. One more test is also there. Legal test. Okay. So here also by using legal test, we can differentiate between aldehydes and ketones. Okay. So in legal test, wine red color solution is formed when aqueous solution of acetone is treated with freshly prepared sodium nitroprusside in NaOH. Okay. So sodium nitroprusside in NaOH, that is called legal reagent. Okay. So it forms wine red color solution with the acetone. Okay. So legal test. Sodium nitroprusside in NaOH. This is called legal reagent. Forms wine red color solution with acetone. This is test for ketone. Acetone. Okay. So with the addition of legal reagent, acetone forms wine red color solution. Okay. So all these are different identification tests for aldehydes and ketones. Okay. Next, coming to oxidation of ketones. Oxidation of ketones. Oxidation of ketones. So ketones, for example, acetone is there. When it undergoes oxidation in presence of concentrated nitric acid, we get mixture of carboxylic acid, both formic acid and acetic acid. So acetone, it undergoes oxidation in presence of concentrated nitric acid. Okay. So here we get mixture of carboxylic acid, formic acid and also acetic acid. Okay. So this is general oxidation reaction. So oxidation with the sodium hypohalite. Oxidation of ketones, which are also called as methyl ketones. Okay. So oxidation of methyl ketones. Methyl ketones with sodium hypohalite. Methyl ketones, we are using separately methyl ketone. Why? Because in ketones and aldehydes also, methyl group linked with the carbonyl group. Okay, that's why these are called as methyl ketones. Methyl ketones. So when ketone reacts with sodium hypohalite, we get halophor. Okay. So methyl group converts into halophor. Okay. So for example, acetone is there. If it is reacts with sodium hypohalite, NaOX. So X may be chlorine, bromine, iodine. Okay. So here methyl group which is linked with the carbonyl carbon, it converts into halophor. Okay. And sodium group, okay, with oxygen. So NaO group gets attached to this carbonyl carbon. Okay. We get corresponding salts of carboxylic acids. Okay. So CH3COO-Na. Okay. Sodium acetate. We get sodium acetate, salt of acetic acid. Okay. And along with this, we also get CH3. Okay. CH3. Okay. So this is haloform. If it is chlorine, we get CHCl3, chloroform. If it is bromine, bromoform. Okay. So this is sodium acetate, carboxylic acid. So in methyl ketones, alkyl group converts into haloform. Okay. So this is oxidation of ketone. We can identify ketones by using this test.